So the adding, I just put another adding right here too, right?
Mm-hmm. Your answer from before is correct.
Oh, okay.
When you originally had the minus 9 minus 3, what would that equal?
2 positive 12, right?
Mm-hmm. Negative 12.
12, negative 12, yeah.
So we're just changing the work to match up with your answer, but the answer was good before. This one's good here too. Show me what you would have to do to get that though. All right. We are going to go ahead and get started. So these are like 4 quick warm-up questions from what we did yesterday. Yesterday we had talked about solving one-step equations. In order to solve an equation, what are we always going to do?
The opposite.
Opposite, perfect. So for an equation like this, if we want to solve for x, what would I need to do to solve?
Subtract negative 4.
Mm-hmm. Just subtract. Subtract 4. If you say subtract negative 4, too many negatives. So we could say subtract 4 on both sides. That leaves us with x equals 8. I'm going to pick one more. What about number 3? What would I need to do in number 3?
That would be division.
Why would it be division?
Because the negative 6t is a multiplication.
Nice. So this was something we had seen a little bit back at the Intro to Variables lesson. We reviewed it yesterday. If you've got a number and a variable right next to each other, that means multiplication. So you said we want to divide. We want to divide by what? Why'd you change it to negative 6? Mm-hmm. Yep. So negative 6 divided by negative 6. You're on the other side. Negative 6 divided by negative 6?
0.
It cancels.
It cancels, but what does it equal? It equals t, but I want to back up. What is negative 6 divided by negative 6?
1.
1. So we get 1t, which we had talked about. 1t is just the same thing as t, which you told me. And then you were trying to do this side too. 18 divided by negative 6? Why is it negative?
Negative 6 times negative 2 is positive 8.
Ooh, you're flipping it back to multiplication. So negative 3 times negative 6 would give us positive 18. We also learned when you're multiplying or dividing different signs, the answer is negative. The other thing I hear you doing is this idea of how you can check your answer. And I saw on your paper you were giving me beautiful checks. How could I check my answer for any of these?
Negative 6 times negative 3.
Do you remember what that's called, what you just did there?
Substitute.
Nice. Substitute. When we substitute, we're checking to see, is it true? Is negative 6 times negative 3 18? Yeah, that's what you told me a moment ago. With that, I think we are warmed up. I'll go ahead and get us started. Yesterday, this is what we were looking at. What we call one-step equations. One-step equations because there's one thing you have to do. Today is two-step equations. So you can probably guess that means there's going to be 2 things we need to do. I talked a little bit about it yesterday, but I'll say it again, especially since I didn't see either of you yesterday. When you're talking about solving equations, everything we said yesterday will always be true. Solving an equation means getting the variable by itself. Francis, you told me at the beginning, in order to solve, we're always doing the opposite operation. That is going to be true no matter how many steps there are. What happens with equations is you just keep building on what you know. So yesterday we did one-step equations. Today we're doing two-step equations. You can imagine very soon in the future there'll be 3-step and 4-step equations. But everything we've been doing is true. You're just using that to solve equations that are even more fun. So to start us off, I've got a couple questions here. I'm thinking of a number. Do you know what my number is?
1.
Do you know what my number is? Not like guessing or anything. It's not a trick question. Do you know?
No.
No, of course not. You're not in my head. So if you don't know what my number is, what could we write down to represent my number? You can't write down a number because you don't know it.
X.
We could use a variable. Sure, let's use x for my number. X is going to represent that number I'm thinking of in my head that you all don't know. I'm taking that number you don't know, and I'm going to multiply it by 3. What could we write down to represent that?
3x.
Beautiful. You did 2 things right there automatically, which I love. One thing is to show that multiplication, you just put them together. You didn't say 3 times x, you just said 3x. And then the other thing, which we don't talk about enough, is that number is always in front of the variable. We don't see x3, you see 3x. And I hear you laughing, which is good because you already know that doesn't look great. So we get 3x. Okay, I'm taking that new product, to use math vocab, but that new amount in my head, and now I'm going to subtract 4.
3 times -4.
-4.
I hear that. Does that represent the new amount I have? I'm taking what I had before and then I'm subtracting 4. So I need more stuff here.
So
So 3x -4.
Yeah, 3x minus 4. I'm taking this amount and subtracting 4.
Oh,
So to show that,
look, I said that, but okay.
I heard you say 3 times
I said
-4.
3. Oh, my bad.
Maybe you're thinking of that as the multiplication x. But that's a sign y. It goes back into what we've been saying, right? That's why we don't use that multiplication x nearly as much now. The last part, I'm going to finally tell you what I've got. My answer equals 11. Finish it all up.
So 3x minus 4 equals 11.
Perfect. I'm going through this to show a couple things. The first thing is this is a 2-step equation. There's a couple things different about this equation compared to what we looked at yesterday. What's some of the things you noticed that's different about it?
Well, over there when I was looking at her notes,
Mm-hmm.
it's not like you have to, like, you know how you just leave out the negative, you just put 3, let's say 3x equals 12. Yeah, you have to do 3 equals 3, then equals.
Yep, you're going into the solving, but what you've pointed out is before there was only one number. You said yesterday I was leaving out that -4. Now there are 2 numbers with our variable. Goes back into this idea that it's a 2-step equation. There's going to be 2 numbers I have to get rid of to solve for x. Part of the reason there's 2 numbers on that side with our variable is because there's 2 things I did to that number. I multiplied it and I subtracted it. So in order to solve for our variable, there's going to be 2 things I have to do the opposite of to solve. The last thing I talked about yesterday is, yesterday I said there's going to be a lot of 1-step equations you can look at and you just know what the answer is. Carlos, I saw in those warm-up questions, you weren't having to do any work. You were just, I know the answer. I'm going to put down the answer. As these equations get bigger, it is harder and harder to just look at them and be like, I know the answer. Maybe you know this answer. Maybe you at home know this answer. But oftentimes, the more things you do to the variable, the more things that are happening to x, the harder it is to just look at it and be like, oh, of course, the answer is 100. That's the reason we learned all those steps yesterday, is because no matter how crazy the equation looks, all those steps we were doing yesterday are going to be the same things we're doing today. Does anyone have an idea of what that variable is? I can put our guesses up here.
So 3 times 5 equals 15, so minus 4 equals 11.
You think 5 maybe? Do you have a guess? Not sure. It's okay. It's great actually if you can't look at it and figure it out, because that just makes all the algebra we were learning way more useful. So we got one guess, we got, we're not sure. We're going to talk about in a moment how you solve this, so we'll find out in a moment if you're right.
I hope.
Well, if you're not, it's okay too. Before we solve this, there's some vocabulary I want to put with it. It just helps talking about the equation easier. Instead of saying like, oh, that I have to get rid of that number. There's names for each of those numbers. So the first number, this number here, the number in front of our variable, we've learned that word before. Do you remember? Yeah, coefficient. We had learned with combining like terms, coefficient is the name of that number in front of the variable. The other number on that side with our variable, in this case that -4, also has a name? Do you know? Wherever would you get that word? Yes. But yeah, that other one there is our constant. So coefficient, maybe you can fill in the blanks now. Coefficient is the number. Ooh, yeah, before a variable. I've never put that word in that blank, but we could say before a variable. I always say in front of. But these are for you. So if you think of before, it's however you think of it. It's in front of the variable, it's before the variable. And then just an extra part to our definition, what type of math is happening there? Yep. So we'll say it's a number in front of a variable that is multiplied. Just a nice reminder of what math's happening there. And then your constant, that number by itself, is always going to be the number that is added or, yep, sounded like a math teacher, added or subtracted in the equation. Part of the reason I want you to know these names is because it means instead of you saying, oh, we got to get rid of that number, you can say, oh, we have to get rid of the constant or the coefficient. It helps you be more specific. The other reason I want you to know these is because when you are solving these equations, there's always a specific order you solve them in. And that order is you always start by getting rid of the, no, you had a 50-50 shot, the constant. And then you get rid of the, there you go. So knowing what we know now, we're going to go back to that equation, that 3x minus 4 equals 11, and we are going to start solving that equation by getting rid of the constant. I'm going to put it over here for us. In this equation, what's our constant?
The 4.
Which one? Final answer.
-4.
Good. And I like how you changed it to say -4. In order to get rid of that constant, use what we learned yesterday. What do you think I'm going to need to do?
Divide 4.
Divide by 4? Agree? Not sure? Not sure. Tell me why we're dividing.
Because you always do the opposite of what your problem is.
Love it. We always do the opposite of what our problem is. What operation is that?
Is
Subtract. So I was going to say, take that advice you just told me. We're going to do the opposite, which is add.
So add 4, after that under 4, 11 on that, add 4, it would equal 15.
I love how you're doing that. So you said 11 plus 4 gives us 15.
Yeah, so
What about on the, wait, I know because you're just, you're so quick with these, but slow down for a second. What's going to be on this other side here?
X.
3x. We still have that 3 there. We haven't done anything with the 3 yet. What happened to my 4s?
It's gone.
Cancel out
Why did it cancel out?
because it equals 0.
Ooh, love that. -4 plus 4 gives us 0. Means it's nothing. It's no more. It cancels out. So we get our 3x equals 15.
So it would be x equals 5.
How are you getting that? How'd you get x equal?
3 times 3 divided by 15 equals 55.
Okay. I'm going to change what you said. Instead of 3 divided by 15, we're doing 15.
15 divided by 3.
Why are we dividing?
Because it's a multiplication.
Yeah. Yep, it's a multiplication right here. That 3 times x, so we're doing the opposite. Same thing we set up here. So when I go to divide by 3, I think you already said it, we get x equals 5. What happened to my 3s? Why did it cancel?
0.
0.
3
Because
times
3 divided by actually it's 1.
I could hear you both at different times going like, wait.
X is 1. Okay.
3 divided by 3 is 1. Not x is 1. X is 5. But that number in front of x, that coefficient, if you will, is 1, and we know 1x is the same thing as x. Notice you're using all the stuff you learned yesterday, right? This idea of doing the opposite operation. It's just going to take us 2 steps to get to our answer. And Carlos, look at you. Woo! Also the same as yesterday. I love checking my answer. If you guys have not noticed, I will always tell you how to check stuff if you're able to check. We learned this idea yesterday. I saw you doing it like 20 minutes ago. How do you check your answer?
5 take away 11.
Not quite. How are you doing it on the do now? Those questions at the top of the page.
What?
Take
Because you can do, I'm trying to flip it around. I don't remember. So it was no, what was it? You could put 15 divided by 3 minus 4 will equal 11. And you can flip it. Can you flip it around? Or no?
There was a math word we said at the beginning of this lesson. In order to check, you have to, remember? You told me this. Substitute. So what does it mean to substitute?
Put it all together.
What do you mean put it all together?
3 divided by 15 it was. Minus 4.
Checking your answer requires you to use this equation.
Oh, to use that same equation?
Mm-hmm.
Oh.
So if our equation is 3x minus 4 equals 11, how could we check our answer?
Well, I just do the same thing as 3 divided by 15 minus 4 equals 11.
That's just you doing the solving again, though. There's something different you do to check. Let me change the question then. When we say we're solving an equation, what does that mean?
Solve is that how you got how you got the answer, right?
11 plus negative 4.
No. I'm not asking how you check anymore. I'm just saying when we say I'm going to solve an equation, what does that mean?
So solve the equation from the how you got that answer and you just fit it in
I'm not asking how you solve an equation.
Oh.
I'm asking what does it mean to solve an equation? You said something about what I heard you say fit in. What do you mean by that?
It's like take the answer you
Mhm.
got and put it in the question thing.
Yeah.
The problem.
When we're solving an equation, it means we're trying to figure out what number x is. We're trying to figure out what number goes here.
Yeah, like 5. So
To
3
make
times
this true.
5 minus 4 equals 11.
There you go.
Okay.
In order to check our answer, we want to make sure we did exactly that. If I'm trying to figure out what number goes here to give me 11, we do exactly what you just told me, which is substitute, to put that word you said earlier. But substituting means what you just said. It means putting that number there to make sure we did what we were out to do. We were trying to figure out that number that gives us 11 here. So let's make sure if I put 5 there, 5 is indeed that number. So I heard you say it. Will you say it again?
3 times 5
Mm-hmm.
minus what, negative 4?
Just minus 4.
Yeah.
Mm-hmm.
Equals 11.
Yep.
So
And at a check, we want to make sure, did I do it right? Like, did I find that number to give me 11?
So first you do 3 times 5.
Mm-hmm.
That's 15 minus 4 equals 11. Man, that's right there.
Oh, yeah, that's right. I asked this question in the lesson yesterday, but I didn't see you both yesterday, so I'll ask it again. How many different numbers can I put here so that this entire side gives me 11?
What?
How many different numbers can I put here for x so that this side here equals 11? You told me 5.
Yeah.
That's one number.
Yes.
Are there other numbers I could put here?
So I did this. So 3 times 4 equals 12 minus 4. That's going to equal 8.
So you figure, okay.
I did 3 times 5 minus, 3 times 5
3. Mm-hmm.
minus 12 times, it will equal 15 minus 4 will be 11.
So I hear you saying 4 doesn't work.
Yeah, and
5 does work.
Yeah, I did 3 times 6 be 3 plus 4, that'd be 14.
So I hear you're saying 6 doesn't work.
Yeah.
Is there any other number I can put here?
No.
No. So when we're talking about solving equations, our goal is to find the one and only number
Yeah.
you can put in that spot to make it 11. And when we solved this, we figured out that one and only number was 5. Remember, this came from what number am I thinking of? I was only thinking of one number. I wasn't thinking of like multiple numbers that all gave me 11. That one number I was thinking of was 5. And when you multiply 5 by 3 and then you subtract 4, it leaves you with 11. How are we feeling on this? We over this problem? We want a new problem? So Carlo showed us he is excellent at looking at that two-step equation even and figuring out what that missing number was. But I can throw some curveballs at you. I think things that could make that more challenging is if I give you negative numbers, if I start giving you decimals. How are we feeling about this one? Can you just like look at it and know what the answer is?
Alright.
It's all right. Maybe you can't look at it and know what that missing number is, but we can look at it and we are hopefully getting more comfortable knowing what we need to do to figure out that missing number. So if I wanted to find y, if I want to solve for y, what's the first thing you want to do?
The 5.8, so plus 5.8.
Nice. So you started with the 5.8. Could I have started with the negative 2, the 7?
Nah.
Why are we starting with that 5.8?
Because the most important is to solve the y.
We want to solve for a y.
Yeah.
What is 5.8?
Uh,
Q, math, vocabulary.
what was it?
Cancels out.
What was it?
You're talking about the math. I'm asking what is it? It's the constant.
Yeah.
Mhm. So we're starting with that 5.8 because it's the constant. And when you add 5.8, Francis, I heard you saying cancels itself out because it equals. Yep. When I do that, what does that leave me with?
So negative 2y equals 12.8.
Nice. What else you want to do?
And after that, you need to do negative 2 divided by 12. 12.8 divided by 12. There you go.
Nice. I like how you caught yourself and flipped it around. Why are we dividing by negative 2?
Fine. Well, it's not a multiplication problem.
Yeah.
It's a
Yep.
division.
Yep. This is multiplication, which means we need division. When I do that over here,
So that cancels out.
cancels out because it equals
0. Well, y is y1 is 1. Y.
negative 2 divided by negative 2
1.
is 1 y or y. Eventually, we're going to get to the point where I ask that and you don't tell me 0. We get y equals, what about the other side? 12.8 divided by negative 2?
I think 2.4. I think that's what I think.
We could always divide. I'm going to leave off the negative for now. How many times does 2 go into 12?
6.
Any remainder?
Nah, that'd be 12.
6.4.
Right after 8, that's gonna be 4. Oh yeah,
Yeah.
right then. 6.4.
You said 2.4, but maybe this is the what was
6.4.
6.4.
Yeah. After that, if you want to check it, so it would be
Whoop.
negative 2 times 6.4. Negative 5.8 equals 7. So negative 2 times 6.4 will equal 12.8.
Negative 2 times 6.4.
No.
Negative 2 times 6.4.
Oh yeah, I'm right. Okay, yeah. No, wait, negative 12.
Okay.
Negative 5.8 equals 7.
What happens when you've got two negative numbers?
You can put the parentheses. I think no.
You could. It's not necessary. What do you do mathematically when they're both negative?
Yeah.
You add them. So is this going to give me 7? If you add 12 and 5, is that going to give you a 7? No. I mean, somewhere there's a mistake. Go back up to that last part here. Somewhere in this area. Yeah, we had a positive divided by a negative. Different signs means it's negative. I was kind of like looking at you guys, but you just jumped right into the checking, which I also love. I love checking. But this was a great opportunity to show how checking can help you figure out something is wrong. Now in the future, you won't have me circling the area the mistake is in. You'd have to look at the whole thing, but it's a great example of why we check. So if I do make that negative, -2 times -6.4 gives me negative times negative gives me positive.
Yeah.
And then when I do subtract those, I already heard you say, yep, it would give me my 7. So now we're happy. How are we feeling? I think this last one here will be the last one we do together, and then I'll give you guys an opportunity to try some. For this one here, talk me through. You guys are going to lead this one. What's the first thing you want to do?
So plus 6.
Agree?
B plus, I'll be negative 6.
Plus 6 or minus 6? You want to explain to each other why?
Because if you add 6 and 6, you get 12, and you gotta cancel it out to get nothing.
Has she convinced you? So you said if we added 6 on both sides, what's the problem with that?
Wait,
6 plus 6 is 12.
6 plus 6 would give me 12.
Oh, yeah.
So did she convince you?
Yeah.
What do we want to do then?
Subtract 6.
Okay. What I love that you both did is you went to 6 and not this number here. Why 6?
Because we figured out the letter D.
We're trying to solve for D.
Yeah.
Tell me more specifically, why 6 and not any of the other numbers?
Because the answer is 27.
So we're not touching 27.
Right.
So why 6 and not the 3?
Because we're figuring out.
Multiplication.
Because that's multiplication.
Yeah, but we figured out the one number that fits with D. After that, we check out what fits the number.
You're just like describing solving equations, which is good. My question is, why are we starting with the minus 6? Why couldn't we start with the 3? You said it was multiplication.
I'm stuck at describing that.
You're the one who told me earlier.
Got it ready.
Cue the math vocabulary.
Oh, constant.
There you go. Constant. It's that number by itself, which in general, that's the number we always start with. So I'm going to start with my constant, 6. We agreed we're subtracting 6. What's that going to leave me with?
Let's be 21.
So I'm hearing 21 from Carlos. Francis is telling me the 6's cancel.
Yeah.
21 minus 3D.
Carlos, agree? Disagree?
Yeah, I agree.
Looks good?
Yes.
All right. You want to keep us going?
And after that, so you just put 3, negative 3.
Where?
Under the 21. And after that, so put the line.
All right. What's that line mean?
Division.
Division?
Yes.
Mhm.
And the same as the other side, negative 3. So that cancels, and we stay with D.
What cancels?
The negative 3 with negative 3.
Why does it cancel?
Because it's 0. But it has D though. Right?
Negative 3 divided by negative 3?
It cancels. Oh.
D is 1.
It's 1.
Oh, yeah, D.
3 divided by 3 is 1. Same thing with negative 3 divided by negative 3. So it gives us 1D
Or just D.
or just D.
Then
Okay.
after that, so negative 3 divided by 21.
7.
What 21 divided by negative
21 divided by negative 3 is
7.
Negative 7.
why negative?
Because the negative 7 times negative 3 will equal about 21.
You agree? All right. So negative 7D?
Equal.
Good. So up here, the only thing I would change is I probably would have put an equal sign there because